In these early days, we explored all sorts of power reactors, comparing the advantages and disadvantages of each type. The number of possibilities was enormous, since there are many possibilities for each component of a reactor. Fuel, coolant, and moderator. The fissile material may be uranium-233, uranium-235, or plutonium-239. The coolant may be water, heavy water, gas, or liquid metal. And the moderator may be water, heavy water, beryllium, graphite, or in the fast neutron reactor, no moderator. I have calculated that if one counted all the combinations, one could identify about 1,000 distinct reactors. We had to choose which possibilities to pursue, which to ignore. In 1946, one of my colleagues and I had written a paper called Pressurized Water as a Coolant and Moderator. We gave the possibilities for what later became the pressurized water reactor, just a short memorandum, about 3 or 4 pages long, and it looked like it would be a feasible thing to do. Let me explain how this works. Useful work can be extracted efficiently from a nuclear chain reaction only if the coolant operates at high temperatures.
The typical temperatures in a light water reactor of the water entering and exiting the core are around 300 degrees Celsius. But at these temperatures, water under atmospheric pressure would boil and become vapor very quickly. So we need to pressurize the water to make sure it retains its liquid nature long enough in the core to remove effectively the heat.
So, when Rickover came on the scene, I naturally called his attention to the ideas we had developed on the use of pressurized water. For a submarine reactor, pressurized water had 2 main advantages. First, a reactor based on it would be small enough to fit comfortably in a submarine. Second, water was something the Navy ought to know about.
I'll now show you how this works. Watch the control rods come out. As the control rods come out, the reactor starts, the water starts in circulating through here, the steam starts in going this way, drives the turbine, which drives the propeller.
At the National Reactor Testing Station, the reactor was placed in final assembly.
Thus was born the pressurized water reactor. Not as a commercial power plant, and not because it was cheap or inherently safer than other reactors, but rather because it was compact and simple and lent itself to naval propulsion.
At Groton, Connecticut, a new naval era dawns with the launching of the Nautilus, one of the largest submarines ever built, and the first atomic-powered craft in history. It may well.
But once the pressurized water reactor was developed by the Navy, the system achieved dominance for central station power.
Limited only by its cruise endurance. At once a formidable fighting ship and a forerunner of commercial atomic power, the Nautilus heralds a new era of the atomic age.
And that famous man in charge, Admiral Rickover, he was also a member of the Atomic Energy Commission, so he had a civilian hat and a military hat. And in fact, he used to write letters to himself, basically, and say, Dear Admiral Rickover, from the Atomic Energy Commission on the civilian side, we would like to have a submarine with a nuclear reactor. And he would write back, Dear Admiral Rickover, from the submarine, we're working on it, don't worry about it, just give us some money. So as soon as it was over, there was no daylight between the civilian and the military. And as soon as he'd finished it, of course, they could take his work for the submarine and start building nuclear reactors, which is what they did.
the nuclear industry was born. Where did Oak Ridge National Laboratories fit in the...
Thorium, the energy.
All right, you win. But let's make it short and simple, for now at least. Norway was where thorium was first discovered, so let's start there.
This is Lövøya Island. This small pit is the remains of the original site where thorium was first discovered in the 1820s. And the local vicar, who was a mineralogist of passion, he went out here to hunt ducks, but he hunted something else. He found the new minerals. And that new mineral he didn't know. It was a brownish stuff. He sent it to the famous chemist in Sweden called Jaak Berzelius, now called the father of modern chemistry. And he was eager to look into this, and he became very enthusiastic because this was not only a new mineral, it was consisting of a new element. And he discovered that this was a very special kind of element, and he named it after the Norse god of thunder, Thor, and then it was named thorium.
Thorium and uranium was created in one or several supernovas over 6 billion years ago, when the solar system and the Earth was created. And this is why it is embedded in the Earth crust at various concentrations throughout our Earth.
So, there are two potential nuclear fuels, uranium and thorium.
Thorium is a little bit lighter element than uranium. Uranium is element number 92, and thorium has 2 less protons, so it's element number 90. It's a so-called fertile material. It means that it can't fission directly. Uranium can fission directly, but thorium can capture neutrons in a reactor and become a type of uranium, and an isotope of uranium that can fission and release energy.
When a nucleus absorbs a neutron, the nucleus can split into fission fragments, and that is fission, or the nucleus can retain the neutron and through radioactive decays can become another element. And this is the case of the so-called fertile species. For example, when thorium-232 absorbs a neutron, it can become uranium-233. So uranium-233, like plutonium-239, are fissile species. They do not exist in nature, and they can be generated in a nuclear reactor as new fuels.
Uranium-233 being fissile, it could theoretically be used in a bomb. However, it was soon pointed out that a bomb made of uranium-233 would always pre-detonate.
You may say that nuclear power was born with original sin, because the first purpose was to make the bomb and the Manhattan Project. And maybe the choice of uranium rather than thorium had something to do with the fact that uranium could be used for bomb purposes. So that has always been part of the image of the nuclear power, the link to nuclear weapons to Hiroshima.